This is chapter 24 on amines and heterocycles. Recall that an amine is a nitrogen-containing organic compound. So trimethylamine is one of our simplest amines. They're all derivatives of ammonia, NH3. So amines themselves are very widely found in nature. Take a look at nicotine. It has aromatic amine heterocycle. It has a aliphatic amine heterocycle here. Take a look at cocaine right here. Very interesting structure. Look at this structure. It's bridged bicyclic. It has a 1, 2, 3, 4, 5, 6, 7 membered ring in it with a nitrogen spanning 1, 2, 3 carbons 1 and 4 of that 7 membered ring. Very odd structure. And for those of you who are interested, at the very end of chapter problems, there's a synthesis problem for cocaine. So be sure to check that out. We can classify amines as primary, secondary, or tertiary, and it's important you understand that this is just based on the actual number of alkyl groups attached to the nitrogen itself. So if we look at trimethylamine, there are literally just 3 R groups attached to that N, so that's a tertiary amine. If you look at tert-butylamine, right, that's an NH2 with a T-butyl group attached, there is only 1 R group attached to this nitrogen. Anything with an NH2 is a primary amine because it has just this one single R group attached. Now, notice this is different from how we classify alcohols. A tertiary alcohol would be something like tert-butyl alcohol, where instead we look at the carbon next to the OH and how many R groups are attached to that. Okay? With amines, we look directly at the nitrogen. So that should be clear. A quaternary ammonium salt is a compound where nitrogen has 4 alkyl groups attached to it. So an N with 4 bonds has to have a positive charge, so it has some sort of negative anionic counterion, like chloride or fluoride or bromide or something like that. So these compounds are named like ammonium, saying which R groups are attached to it. Got a little puzzle for you. I think if you've been understanding our nomenclature rules, you should be able to figure this out. If I have a nitrogen, if I have 4 N-butyl groups attached to it, so that's a 4-carbon chain, and I'm going to put 4 of them. So I'm just making 4 zigzags coming from that nitrogen. So N is a plus. There's a F minus as the anionic counterion. This compound is called TBAF, T-B-A-F. And if you know something about our nomenclature, you should be able to figure out why it's called that. So think about that for a little bit. But TBAF is a very common reagent used. It's actually used to deprotect alcohols from TMS groups and other similar silicon protecting groups from oxygen.